Right. I'm going to talk about Elon Musk and how he brought his spacecraft back to Earth. And it's going to be a sort of very quick explanation because you don't want to go too much into the science because, you know, it gets a bit dull. But shortly after a stage separation, so that's when the rocket kind of falls away from the front bit that's going off in space, the cold gas thrusters will kind of flip the thing around and then it's pointed in the right direction to come back into Earth. And it's going to enter the Earth atmosphere and not burn up because we fired our main engines and that sort of slows it down as well. And then if you watch the video, you see the sort of square things flip out from the top and those are called grid fins. They're there to sort of act as sort of aerodynamic surfaces, and these surfaces steer the rocket down while it's going Mach 4 through the atmosphere. 4 times the speed of sound, for anyone who doesn't know Mach. So close to the ground, those grid fins and the cold gas thrusters that sort of flipped it around earlier, and also the steerable main rocket engines, so that's the big engine at the bottom, they all fire up and they all use control of the landing and make sure it comes down very gently and actually quite hard on its carbon fiber legs, which are sort of spread out as well. The best way to think about this rocket engine at the bottom trying to balance it is if you were trying to balance a pole on the end of your finger and your hand kind of moves around all over the place just to counteract where that pole's going. It's kind of like that. So that's a very basic idea of how that rocket landed, and I want to now go on to the future of space travel because that's more interesting. So the future of travel, well, in the short term, there are some very clear goals we've set out. We want to investigate asteroids, and these are the kind of those bits of rock and ice floating around in space that are actually full of rare earth metals. And we can go and mine those metals and make lots of money by bringing them back to Earth because they're rare earth, so we need more here. Another goal is to visit Mars, and this is not just sending another rover. We are planning to send humans, and this is obviously one of those big stories that has been in news loads because everyone wants to go to Mars and it'll be fun. So we want to know really whether we can survive on another planet and whether we can colonize it, whether it's feasible for us to do it. The planet we're on is in a sort of privileged position. It's in what we call a Goldilocks zone. It means that planets there are conducive to life. It means liquid water can survive on the surface of the planet or exists on the surface of the planet. We do have a problem though, and that problem is also our saviour, which is the sun. It gives us energy, gives us life, but it's going to kill us because it grows, or it will grow. It's actually going to swell to the point it almost swallows the Earth. And so that means we're going to have to leave the Earth if we want to survive as a race. So if we don't press our own self-destruct button, as hard as we are trying, we're going to have to start planet hopping. And that's where going to Mars comes in, because that's our first hop, I suppose. So if we can survive on Mars, we can go further. So I want to think of a few different ways of reaching distant stars, and that's in terms of propulsion. There are many different weird and wonderful ways of propelling ourselves into the dark abyss, but a couple I've picked out, well, the first one is nuclear fusion. So this is the fusion of light elements. When you fuse these elements, a lot of energy is released, and the exhaust velocities from these rocket engines essentially could be in the region of 4 to 10% of the speed of light. That is very, very fast. Countries have dabbled in the idea of setting off nuclear bombs behind the spacecraft and sort of riding the wave. And there is a slight problem in nuclear fallout on the planet, so they've kind of been ruled out. What a lot of people think about is when they think about sort of the future of space travel is the warp drive. And it's the kind of thing you see in Star Trek, and everyone wants one because we're going to go to other planets and it's going to be amazing. But it is a theoretical engine at the moment. There's something called the Alcubierre drive. This drive works on the principle of creating a warp bubble around your ship and then contracting space-time in front of the bubble and expanding it behind. And that will sort of push our bubble through space. And within the bubble, we're not actually breaking the relativistic rules. We're not traveling faster than light. But outside the bubble, we are. There are a couple of problems with this at the moment. Well, there's more than a couple, but I'm going to talk about a couple. If you think about it as you're traveling through space, you're going to collect a lot of matter at the front of the bubble. And so when you suddenly come to a halt at your destination, all that matter at the front of the bubble actually will likely fly off and will devastate anything you've just arrived at. To recap, in the short term, we're going to go to the asteroids nearby, and then we're going to go to further distances and hopefully find some wonderful planets around some distant stars on some magical warp drives. It's all very exciting. I can't wait to see what we get. Please don't forget to subscribe.